Exactly. I better shut up now, right? All right, so we're going to do 15 really quick. We should know this. I mean, what is this? Its parent function is a quadratic, right? So it looks like this. And it shifts where? What's it shift? Yeah, up 6. Right? So it's just going to go 1, 2, 3, 4, 5, 6. Right? And then go up. And if we graph that, we know that a regular quadratic goes up 6. Say 1, 2, 3, 4, 5, 6, right? And then goes over 1 and up 1. Right? And then goes over 2 and up 4. Right? Because 2 squared. Right? So it's still going to follow that same kind of basic quadratic. 1, 2, 3, 4. Right? So it's still following that basic quadratic. This is your basic quadratic. Okay? Now it's equal to, so it's a solid line. And it's greater than, so where do we shade? Up, right? So you put your pin on here and you shade it up. That one's cake. Yum, yum, yum. I'll eat that all day. Okay? Now this one's going to be a little harder, right? Because this one's an actual quadratic. Well, we know it's shifting. We don't see it in the actual, we don't see it in the vertex form, right? So we don't know how much it's shifting. This is a basic quadratic. Cool part is if I want, I can try to factor it. The factor is basically product and sum. The product is 6. The sum is 2. Two numbers that multiply to be 6 but add to be 2. Nah, I can't factor it, right? So the only way I'm going to deal with this is either quadratic formula, right, or the 4-step plus 1. I like 4-step plus 1 because you plug in zeros and it's all good to go, right? Easy stuff. But this is just back to what we've been doing, how to graph a quadratic. Okay? First step is find f prime of x is equal to 0. That's your axis, right? Another way to remember this, remember quadratic formula is ax squared plus bx plus c, right? That's where it all starts. That's where it all begins, a, b, and c, right? The first way to think of this number 1 step is basically just 2a plus b equals 0 and solve, right? If you don't want to do the calculus, but what I'm trying to set you up for is calculus, right? We're in trig. Calculus is not scary. There's nothing scary about it. 2 times 1 is 2. Take away 1. It's 1. 1 times 2 is 2. Take away 1. There's none. Multiply by none. There's none. Ta-da! Calculus. Alright? That's it. I mean, it's a scary math to everybody. Everybody's like, oh man, calculus is not scary. It took us 17,000 years, or 1,700 years to figure it out. Probably longer than that since we've been on the earth, but I don't know. A few 100,000, or at least about 100,000, give or take. 20 grand. But, okay, science says we've only been here. Well, when I was young, science said we've been here 10,000 years. Now you guys are saying that we've been here about 60,000 years, something like that. So, I mean, it all changes. It's all relative to what we know, right? But this took us a long time to figure this stuff out, calculus. But it's not that hard to do. So don't be scared of it. That's my point. But if you are, do this. 2a plus b. 2a. Right? 2a. A is 1. Plus b. B is negative 2. Right? Plus a negative 2 is minus 2, right? It's easy. Set it equal to 0. Okay? So that's your first step to find the axis of sim. And so I've got 2x is equal to 2. And by now, I shouldn't have to do the extra steps. X equal to 1. Okay? We should be at this point, right? Everybody sees how we get there. Okay? Axis of sim. Now if I want to know the vertex, that's step 2. Step 2 is f of the axis is equal to the vertex. And technically it's equal to the y part of the vertex. But you know, the point is, if I plug this in, f of 1 is equal to 1 squared minus 2 times 1 plus 6. 1 squared is 1 minus 2 plus 6. So minus 1 plus 6. So f of 1 is equal to 5. Okay? So that means 1, 5 is my vertex. It's no different than what we've been doing. Right? It's no different. And at this point in the game, okay? At this point in the game, we should be able to go to step 3 and tell ourselves, okay, f of 0 is equal to 6. So this is 0 and 6. Right? Okay? And then the fourth step, oh, this one's hard. 2 times the axis. So f of 2 times 1 should also equal 6. So that means f of 2 should equal 6. So it's 2 and 6. Now, I need to check that real quick, though. You know, I want to make sure I'm doing things right. So I check it really quick. 2 squared is 4, minus 2 times 2, which is 4, plus 6. Yes, that's right. That is 6. It's just a real quick check. That's all it is. Quick check, and then graph it. Okay? Now here's the graph. I've got a 1, 5, I've got a 2, 6, and a 0, 6, right? So I've got 1s and 2s. So how about I go 1 and 2, right? In the x's. And then I got up to 6 in the y's. So can I just go 1, 2, 3, 4, 5, 6, like that? Right? And so maybe I need to bring this down a little bit so it's not in my way. Okay? So 1, 2, 3, 4, 5, 6. Okay, so I've got at 1 and 5 is my black, is my vertex. Right? At 0 and 6, well, that's my y-intercept. And then my symmetrical point was the purple at 2 and 6, right? And then, so my graph, let's just use another color. My graph looks like this. Now, we're doing a less than equal to, so equal to means it's solid or dotted. Solid, okay? And it is less than, right? Less than tells me I start on this, and where's less than, up or down? Down. So it's all of this. Everything under the graph. So it's graphing the quadratic and then knowing where to shade.